Rev, in Jensen's keynote on Monday night, he said the ChatGPT moment for robotics is coming. What are you up to?
Well, the ChatGPT moment was when the world understood that this new capability had arrived of taking information that humans had produced and placed on the internet and stored on the internet. We collected all that information and we produced intelligence that could do many different things, general purpose intelligence. We didn't quite realize what had happened for a few years until they got to connect with it. Until people got to go to a web page where they could go interact with this LLM, with ChatGPT, and see that this was a step function in capability. The same is about to happen for robotics. That same sort of general intelligence, by collecting information from the world, from the physical world, we're working towards gathering all of that and creating a robot brain. And pretty soon, everybody is going to start interacting with these new agents. But these agents aren't like the ones that are in a web page. They're going to be inside robots, inside autonomous machines around us.
And it's in the physical world. So you talk about physical AI.
Absolutely.
How do you, is that the definition or?
Yes. So the AIs that we have today, the AIs that power ChatGPT, Claude, Gemini, all of these amazing capabilities that we get from transformers and LLMs, they've been trained on information that's available to us on the internet, which is largely information that humans have generated from abstract thought. It's cognitive information. It's language largely, right? That's why we call them large language models, which is a human construct. That happens to be the easiest type of data to digitize. But the AIs that we need in order to create robots, to create agents out in the world, they need to understand the rules of the world, essentially physics. They need to be able to interpret what they experience through sensors and make decisions and act upon the world by predicting what will happen if they make those actions. This is essentially what creatures and humans do, right? We interpret the world around us. We make some predictions about what will happen if we push something, or we activate our legs, or press a button. We have some understanding of how it works. And so to build these robots, we need to create a new kind of artificial intelligence trained on information about the physical world. And so that's what we're building now. We've been hard at work building all of the tooling and the platforms necessary to train these kinds of physical AIs. The data sources don't just exist out there. You can't just go to the internet to go get that.
Pull them down.
So we're going to have to collect some of that information from the real world. Then we're going to have to generate most of that information from simulation.
Now, you mentioned you've been building the tool sets and all of this. You didn't come up with this over Christmas. You talk about Cosmos, and you have the World Foundation models. You have the mega blueprints. You have NEMO, NIM models, and. It also ties all back into what you're doing with Omniverse. And you made a comment yesterday in the briefing in terms of you've had a plan on this for a while. This isn't brand new. Could you kind of unpack, for many folks, a lot of the things I just said, they'll go, what are those things? Can you kind of unpack how you kind of put this together?
Sure. Going back to the beginnings of when this whole deep learning, machine learning, AI revolution started. It was in 2012 with the creation of AlexNet. We understood that the most valuable AIs were going to be ones that are related to the physical world, because even the very first deep learning network, AlexNet, was about the physical world. It was image classification, interpreting what's inside an image, discerning between cats and dogs and airplanes and whatever it sees in the image. That was something that we'd been trying to do for decades in computer science, and no programmer, no computer science had cracked that problem. And we had no line of sight to crack it. To this day, a human can't write that. Well, we thought, now that we can actually solve this problem, what are all of the other algorithms, all of the other AIs that we can create about the physical world that, that we didn't even consider beforehand? We didn't think would happen in our lifetimes.
Yeah.
But to create these AIs, we knew that you need to have enormous amounts of the right data to do that. And quite frankly, it just seems impossible and impractical to collect all of the information about the physical world that we need from the real world. It's just
It takes too much.
time consuming. In some cases, it's dangerous, it's expensive, and it requires a lot of human intervention to go label it, make sure it's accurate. So that quickly led us to the idea that simulation was going to be the key, to be the data source, the renewable information data source for the physical world. So we set about building a platform to build simulators in order to build the AIs we need for the physical world. And we call that Omniverse. That's our Omniverse technology platform. Some of the other things you mentioned, we built NEMO, which is essentially our tooling and pipelines in order to train these AIs, in order to post-train them, fine-tuning, all of the things necessary to do that. And the big announcement at the keynote is Cosmos. This is essentially two sets of things. One is the beginnings of physical AI in terms of a set of models. Just like the large language models, these are physical AI models, world foundation models, that we have trained, where we've used an enormous amount of computing resources, our AI supercomputers, trained for months on the data that we've generated and curated to create some wonderful capabilities that we're giving out openly and freely for others to start from. The other thing that we provide with Cosmos is our pipelines and tooling for actually creating these models. So essentially, we're giving everyone a jump start to start building world foundation models and physical AI, because we're right at the beginning of this. This is going to be a long journey. We're going to keep making it better and better, and it's going to require a whole ecosystem to build all of the physical AI we need for all of the robots in the world. And so, given our capabilities as NVIDIA, our particular skills and our resources, we thought the best thing to do here would be to jumpstart the whole ecosystem by us donating essentially our effort in this regard.
You mentioned that mentioned during the keynote in terms of, as you say, that you're making it openly available. People can find stuff on Hugging Face and. As we head into 2025, I had the opportunity with yourself to see what folks like Coin Group and others are doing. It's mind-blowing, right? Art of the possible it's there. Who do you expect to kind of start adopting this in the next 6-9 months? Is this because a lot of people will be going, whoa, hang on a second, where do I start?
Well, many of the companies that are adopting it were already highlighted in.
Well, true.
Keynote,
That's true.
right?
It wasn't. Yeah, you had plenty of reference cases.
So Jensen talked about 3 types of robots that are starting to be ubiquitous and will be in the billions out there. The first kind are knowledge robots. They're the AI equivalent to knowledge workers. They work in the information space. They use computers themselves. Those are what we're calling agentic AI.
Yeah, and we're starting to get familiar with those today.
And so there'll be millions and billions of them forming, because it's very easy to just create more as you need it.
Agreed.
More computers. The other 2 are actual physical robots or physical agents. The first one that is starting to now actually gain some scale is autonomous vehicles or self-driving cars.
Yep.
The whole world hasn't experienced this yet, but if you go to certain cities like San Francisco or Phoenix or Austin,
You will see
it's
some of them.
becoming kind of mundane and unremarkable. You see companies like Waymo have fleets of their self-driving cars everywhere, and this is going to multiply. The third one that we believe is going to be very ubiquitous, we're going to have billions of, are humanoid robots. And the reason for that is for a general purpose robot, the most useful form factor is going to be the one that we can plop into existing environments
That were designed for
that
us
were
humans.
designed for humans. And so these are the three types of robots. Agentic AI, I think people are starting to understand that now. That's a pretty self-explanatory in terms of adoption. There's many companies working on that. Self-driving cars. There's all the automotive companies and all the robotaxi companies out there. And many of those were highlighted in our keynote. And then there's the humanoid robotics companies. There's existing large companies that are doing this now, and there's a whole bunch of startups. It seems like every month there's a dozen new companies producing humanoids because the demand has always been there, but we didn't really have the technology to fulfill.
The enabling bits and pieces weren't there.
And now that we have that with AI, with transformers, with LLMs, moving into physical AI, the general sense, people who are building robotics understand that we have a line of sight now to building these things properly. And so we're seeing a huge amount of investment happening globally in building humanoid robotics.
You know, we met up at Hanover Messe, and I keep saying, hey, you know, it's fascinating times ahead. What we've been chatting about here was a part of what you announced during the keynote. You have digits, there's so much of like, hey, 2025 is going to be a wild ride.
Well, it always is a wild ride with NVIDIA, where we invest heavily and deeply into a vision of the future. We always enter markets that are what Jensen likes to call $0 billion, which encodes a lot of information in there. Essentially, they're not markets yet. They're ones you have to create.
Correct.
But the potential for them to be large is great as well. So we invest for many years and sometimes even more than a decade in there until it finally happens. And then it looks like we just got lucky in general. And so there's a whole bunch of those things that are starting to come to fruition. I think we'll start seeing the beginnings of that this year in terms of physical AI, in terms of robotics.
Well, I said it earlier, we were chatting back, 2 years ago, around Omniverse. You've been putting in the tooling, putting in the platforms, building all the foundations. You've had a plan for a while. Hey, good stuff. Thanks very much.
All right. Thank you.